I've got one last example that is going to show us angle, angle, side. So from our given, we know that angle K is congruent to angle M. They mark it in both our triangles. We know that JK is congruent to JM, and it also tells us that we're dealing with a bisector as well. Most of you are probably going to see JL as part of both triangles. And I bet that you will write down JL is congruent to JL. I'll write it down, but I'll show you that it really doesn't get us very far. But we do know that it is congruent by the reflexive property. So then I'm going to draw that in there. When I look at this, when I put JL is congruent to JL, it doesn't give me any of our four scenarios, like side, 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 angle, side. Some of you might think it is side, angle, side, but remember that angle has to be between the two congruent sides. So it would have to actually be this angle right here in order for it to be side, angle, side. So writing JL as congruent to JL is a perfectly fine step. There's nothing wrong with it. It really just doesn't get us very far. What we do need to focus on is this last portion of the given, which says JL bisects angle KLM. I'm going to find angle KLM, which is this one right here. And if we know that JL bisects this angle, that angle should be split into two congruent angles. We're going to say angle KLJ. Angle KLJ is congruent to angle MLJ by the definition of a bisector. Then we should only have one more step after stating that. So I'm actually going to get rid of a little bit of writing in here. So I'm going to get rid of that, and I'm actually going to get rid of the JL being congruent to JL in the picture. If I look at my picture now, it looks like I have angle, angle, side, which means that our triangles are congruent. So we're going to say triangle JKL is congruent to triangle JML by angle, angle, side.